Welcome to this section of this course regarding hyperbolic functions. Okay. Today's topic is hyperbolic functions of trigonometry. So I will explain what is hyperbolic functions. Okay. Now, in trigonometry, most of the formulas, all formulas are based on unit circle. Unit circle means the circle having radius r equals to 1. Means what? For example, we have this is unit circle. Here x o x dash, y o y dash. This radius is 1. Okay. Here from here to here is 1. Now if any point p of xy, okay. For example, here p of xy is denoted by, let's take any point p is here, x is from here to here to here is x, and here to here is y. Okay, in trigonometry, now this is equals to p of cos theta. Here theta makes positive theta to the positive x-axis. Okay, here as well as cos theta sine of theta. Okay, here x is cos theta and y is sine theta. Okay, here all trigonometric function is based on what? Unit circle, and where the eccentricity, eccentricity is here 0. Okay. Now hyperbolic function. Okay, here hyperbolic function is based on hyperbola. Based on hyperbola. Hyperbola here, this is x o x dash, y o y dash. For example, these are hyperbola. Okay, the equation of hyperbola is given by x square by a square minus y square by b square equals to 1. Now, since it is unit hyperbola, okay, unit hyperbola, okay, here it will be, the equation will be what? The equation will be x square minus y square is equals to 1. Okay. Now here there are two asymptotes passing to origin. One is here y equals to x, another is here y equals to minus x. Okay. Now here any point p where x comma y, okay, here any point p x comma y, this is x and this is y, is defined by p of cos of hyperbolic x comma sine of hyperbolic y. Okay, this is defined by this. Okay, any point in unit hyperbola. Here its eccentricity is what? Greater than 1 for hyperbola. Okay, here eccentricity is 0. If it is parabola, e equals to 1, so it has different concepts. Okay, now let's try to derive the cos hyperbolic, sine hyperbolic, all trigonometric functions, all trigonometric hyperbolic functions. Okay, now from the exponential functions, what we have is, we know e raised to x equals to, we know that e raised to x equals to what? 1 plus x plus x square by 2 factorial. Okay, 2 factorial, sometimes people write like this, or sometimes it is like this. Okay, here 1 plus x square by 2 plus x cube by 3 factorial plus x4 by 4 factorial and so on. Okay, this is what? This is e raised to x. Okay, e raised to x formula. Now what is e raised to minus x? Now if I substitute x equals to minus x, then this equals to 1 as a constant, doesn't affect anything. Here instead of x we have minus x plus here it will be what? Minus x raised to minus x the whole square, which is x square by 2 plus, but here it is odd number, okay? Here minus will come over here, minus x cube by 3 factorial, but here it is even number, so minus will not have any effect, x4 by 4 factorial. Here plus minus plus minus plus minus and so on. Now if I add these two, adding we have here we have e raised to x plus e raised to minus x is equals to, okay, here 1 plus 1 is here 2 plus minus 1 and minus x and plus x gets cancelled, and here what we'll have is this is 2 factorial. 2 factorial is same as 2 because 2 into 1. So if I add these two what we'll have will be twice, okay? Here twice I'll have x square by 2 factorial, this plus this, and this gets cancelled. Here again I have twice x4 by 4 factorial, okay? These are L to n plus and so on, okay? Now here I can take 2 common. If I take 2 common, here I have 1 plus x square by 2 factorial plus 2 already taken common, x4 by 4 factorial plus and so on, okay? This is what, this is 2 into, this is what, this is, we have formula cos of hyperbolic x, okay? Or is implies e raised to x plus e raised to minus x upon, I can send these two down, therefore cos of hyperbolic x is equals to e raised to x plus e raised to minus x upon 2, okay, here. Similarly, if I subtract these two, we can get sin x, sin hyperbolic x, okay? Now subtracting this, I am giving, okay, here subtracting, we have, now I am giving minus over here, okay? And this is e raised to x minus e raised to minus x is equals to, now I am giving minus in this equation, okay? Here I am giving minus, so my plus 1 minus 1 gets cancelled. Here what I will have is x plus x is twice x, and I am giving minus over here, this and this gets cancelled. Again here plus twice I will have x cube by 3 factorial plus these two gets cancelled, okay? Similarly we will have twice x 5 by 5 factorial and so on, okay? Similarly from here we can take 2 common, x plus x cube by 3 factorial plus x 5 by 5 factorial plus and so on, okay? Here this is what, 2 sine of hyperbolic x. Here this is, on the left hand side we have e raised to x minus e raised to minus x, therefore sine of hyperbolic x equals to e raised to x minus e raised to minus x upon 2, okay? Now let's say these are imaginary angles, okay? What is imaginary angles? Imaginary angles is, it has, we have 30 degree, 45 degree, like we have any angles over here, okay? We have from this is 0, 90, 180, 270 and 360. If we start from here, okay, and 360 again, this one, you have many real numbers, okay, here, but here we have imaginary number here, okay, I. Here I square equals to minus 1, okay? Here you can say I equals to square root of minus 1. Okay. Now imagine, similarly in trigonometry what we have is we have imaginary angles. Okay. Here imaginary angle is sine of ix is equals to I into sine hyperbolic x. If it is, then cos of ix equals to cos hyperbolic x. Now what you have to remember is if it contains sine, okay, then I will come out. Okay. If, or you can say it is sine is what? It's a odd function. This is even function. Okay. For odd functions, I comes out. Okay. Even 10 also it is odd function, so I comes out. But here in cos function, I doesn't comes out. Okay. Here sine of ix is same as I sine hyperbolic x. It is, since it is odd function, these two are odd function. Here we have minus I also. Okay, here minus I tan hyperbolic x, cos ix is cos hyperbolic x. Okay. On the other hand, okay, on the other hand, if we have sine of hyperbolic ix, then it should be I come out. Okay, and I into sine x, and cos hyperbolic ix equals to cos x. Okay, here what we have? Okay, here I comes. Okay, here these two odd functions. Okay. Now let's prove some other way in terms of by Euler's formula. Okay, by Euler's formula what we have is e raised to I theta is equals to cos of theta plus I sine of theta. Okay, this is by Euler's theorem. Okay. Now here what is I? I is a imaginary parts. Okay, for all thetas. Now if we have, what is e raised to minus I theta? Okay, minus I theta. Instead of theta you put minus theta. Okay, you substitute. So cos of minus theta is what? Cos theta, because it is a even function. Okay, and here what we have? Sine of minus theta is what? Minus sine theta. It is odd function. Okay, here minus will come out. Here I will have I sine of theta. Okay, what I'm doing is, we have e raised to I theta equals to cos theta plus I sine theta by Euler's formula. Okay, now if I change from theta to minus theta by substituting theta equals to minus theta, what we have is cos of minus theta is cos theta. Why? Because it is a even function. Sine theta is odd function. Sine of minus theta is minus sine theta. Minus come out I here. Now if I add these two, okay, if I add these two, adding, we have is e raised to I theta plus e raised to minus I theta is equals to what? If I add these two, then this will get cancelled. Okay, these two will get cancelled. I will have what? 2 cos theta. Okay, twice cos theta. Now I can send these two down. Okay, I can send these two down. Now it become cos theta is this. Okay, similarly if I subtract, then e raised to I theta minus e raised to minus I theta is what? Now I am giving minus over here. Okay, here plus cos theta minus cos theta gets cancelled. Here it is plus. Okay, here I will have twice I plus I is twice I sine theta. Okay, therefore sine theta will be what? I can send these two I down. Here twice I is equals to sine theta. Okay, now these two we have. Now I want to get into some other hyperbolic function. Okay, now if I substitute theta equals to I x, okay, say this is equation A, this is equation B. Okay, in equation A, we have, instead of theta, you have to put ix. You have to substitute ix. Okay. Now here on the left hand side, okay, on the right hand side, what we have is cos of ix. Okay, cos of ix. Okay, here cos of ix is what? Cos of ix is become a cos hypo. Now cos of ix. Okay, cos of ix is what? Cos of ix is in terms of hyperbolic. What we have? Cos of hyperbolic x. Okay, for the right hand side, for this equation A. Okay, this is same as what? Cos of hyperbolic x is equals to, on the left hand side, what we have, instead of theta, we have to substitute ix. Okay, here e raised to I, okay, into I x. Okay, here I theta, I we already have, instead of theta, I'm substituting what? I'm substituting ix. Okay, plus e raised to minus ix upon 2 is equals to I square is minus 1. Okay, I square is minus 1. What we have is e raised to minus x. Okay, plus e raised to, here I into I is minus 1. Okay, minus 1 and minus is plus. What we'll have? E raised to x upon 2. Okay, therefore this cos hyperbolic x is equals to e raised to minus x plus e raised to x upon 2. Okay, now similarly, if I substitute theta equals to ix in equation B, okay, here in equation B will be on the right hand side, what we have? Okay, we have sine of, instead of theta you have to put ix. Okay, here ix. What is sine of ix? Sine of ix in terms of hyperbolic is what? I comes out into sine hyperbolic x. Okay, this I sine hyperbolic x is equals to, here, okay, here in is equals to, on the left hand side of this equation, what we have? E raised to I into I x minus e raised to minus I into I x upon 2. Okay, therefore this implies we have sine of hyperbolic x. I can send this I down. Okay, here we'll have 2i, and here I into I is minus 1. We have e raised to minus x. I into I is minus 1, minus plus e raised to x. Okay, this is what? Sine hyperbolic x, and this is cos hyperbolic x. Okay, now here you have I. Okay, here I into I is minus 1, so you can say I square. So I square, again we write one step over here. This is same as e raised to minus x minus e raised to minus x upon what? It's a minus 1. 2 into 1 is minus 1, minus 2. Okay, here if I take minus 2, if I take minus common off, then this will come first, e raised to x minus e raised to minus x upon 2. Here minus, so minus gets cancel. Therefore sine of hyperbolic, this is what? This is sine of hyperbolic x. Okay, this is sine hyperbolic x, and this is cos hyperbolic x. Okay, here sine hyperbolic x is minus over here, cos hyperbolic x is here, we will get plus. Okay, now let's discuss most of the all trigonometric formulas and how to write into the its associated hyperbolic functions. The standard formula, you can say trigonometric hyperbola, trigonometric hyperbolic. Okay, the standard formula what we have for trigonometry is we have trigonometry hyperbola. Okay, here we have one, or you can say we have sine square x plus cos square x equals to 1. This is a standard formula for each and every angle. Okay, for all x belongs to any angle. Now, for in this hyperbolic, what we have to do is you have to remember those terms which have sine square. Okay, those terms which have sine square, involving sine square, you change the sign. Okay, change the sign. The term involving sine square, change the sign. For example, even 10 also it involves 10 is what? Sine by cos. Okay, we have sine. So in that term also we have to change the sign. For if you want to write from trigonometric to hyperbolic. Okay, even coshx is what? 1 by sine. Okay, coshx square is 1 by sine square. In there also we have to change. Let's see. Okay, in this one, what we have to do is just write like this. Okay, just keep it as it is. Sine of, for this, sine hyperbolic square x, keep signs aside. Okay, cos of hyperbolic square x is equals to 1. Okay, here you have to change the sign into only trigonometric functions. Okay, here only trigonometric function, since it is constant, so it doesn't have any change. Okay, now here what we have sine square. Okay, sine square function over here we have. If it is sine square, since it is plus over here, we have to write minus over here. Okay, but plus will not change. Why? Because we have to change only the sine square. Okay, therefore this is same as cos hyperbolic square x minus sine hyperbolic square x equals to 1. This is first formula. Okay, second formula what we have is standard one is 1 plus we have 10 square x equals to 1. Sorry, is sec square x. Okay, here you write the constant term as it is 1. You keep blank. 10 hyperbolic square x is equals to sec hyperbolic square x. Okay, here 1 as it is. Now here 10 square is same as sine square by cos square. Okay, therefore in this also will change, since this plus minus will come. Here sec is 1 by cos, so it doesn't have any change. Okay, therefore 1 plus 10 square x equals to sec square x. In hyperbolic form, this is hyperbolic form. Okay, here this is hyperbolic form, and this is also hyperbolic form. Okay, and another is what we have is 1 plus cot square x equals to cosec square x. Now constant term, write as it is 1. If you want to prove, you can prove. Over here, see 1 plus what is cot? Cot is what? Cos square x upon sine square x. Okay, you take LCM, will be what? Sine square x plus cos square x upon sine square x. Sine square x plus cos square is 1 by sine square x is what? Cosec square x. Okay, for this also you can prove, for this also you can prove. Okay, now it is in hyperbolic form. What? Constant keep as it is, keep blank sign, blank, you don't have to write anything. We will substitute here cos square x equals to cosec square. This is hyperbolic. Okay, hyperbolic square. This is also hyperbolic square x. Here hyperbolic. Okay, all are hyperbolic. Now here also cot is what? Cos by sine. Okay, sine is involving, therefore if it is plus, then minus will come. Here also cosec, okay? Cosec also, we can say 1 by sine, okay? Here also, sine square is involving, okay? Sine square is involving, therefore, this is coming, okay? Other formulas, what we have is, we have tan of 2 theta or 2x equals to what? 2 tan x 1 minus tan square x. Okay. Now for trigonometric formula, what we have, tan of 2x equals to 2 tan x upon 1 minus tan square x. Okay. Now keep in mind, we'll change the sign only. It involves sine square x. Okay, sine square. Okay. Here what we have is, it doesn't have any square over here, so we have to change over here. Therefore, tan of hyperbolic 2x is equals to 2 tan hyperbolic x upon 1 minus will come plus over here, okay, because it involves sine square here, okay, 1 plus tan hyperbolic square x, okay. Now 5, we have cos of 2 theta, okay, so x and theta are one and same, okay. If I want to write x, you can write x, or if you want to write theta, you can write theta, okay. So cos of 2 theta is what we have is cos square theta minus sine square theta. We have, again, this can be rationalized as 2 cos square theta minus 1, and this can be rationalized as 1 minus 2 sine square theta, okay. Now if you want to write cos of hyperbolic 2 theta, okay, is equals to what? Now you have to change the sign which involves sine square, okay. Here you will not change anything. Here cos hyperbolic square theta, here we will change, minus will become a plus sine hyperbolic square theta. Here we will not change anything. This will be as it is, 2 cos hyperbolic square theta minus 1 is equals to, here we will change over here, 1 minus will come up, plus 2 sine hyperbolic square theta, okay. Therefore, what you can do is, as you know, cos 2 theta can be written as this also, okay, even this also. Similarly, cos hyperbolic 2 theta can be written either this equals to this, or this equals to this, or this equals to this, okay. This is cos 2 theta, okay. Now another form what we have of sine of a plus b. Formula is what? Sine of a plus b is sine a cos b, sine a cos b plus, if it is plus then plus cos a sine b. Similarly, here sine hyperbolic, okay, sine of hyperbolic a plus b will be same, okay. Here we don't have sine square, okay, we don't have sine square, here all cosine, okay. Similarly, sine of hyperbolic a into cos of hyperbolic b plus cos hyperbolic a into sine hyperbolic b, okay. And if it is minus, okay, if it is then minus, if it is minus, then similarly also minus over here, okay. You can say plus minus, okay. Here plus minus, plus minus, plus minus, plus minus. Similarly, cos also, cos of a plus b is what we have, cos a cos b minus sine a sine b. Here, but sine a and b are different, okay. You cannot say this is, you cannot combine this, these are two different angles, okay. Therefore, cos of hyperbolic a plus b is equals to cos hyperbolic A cos hyperbolic B minus, sign will not change because sine square. This is not square, okay? Here sine of hyperbolic A into sine of hyperbolic B, okay? Therefore, if it is minus, then it becomes plus, minus, then become plus, okay? These are a few trigonometric functions converting into the hyperbolic forms.